Look at a stealth aircraft and something feels wrong. The flat, angular panels of the F-117, the tailless batwing of the B-2, the strange sawtooth edges and the canted fins that lean at impossible angles. These machines look less like aircraft and more like something folded out of dark paper or a prop from a science fiction film. For decades, people have assumed the answer is obvious. They look weird so you cannot see them, but that is the myth. A stealth jet is not invisible, and it was never trying to fool your eyes. Its strange shape is aimed at a completely different enemy, one that hunts with invisible waves, and every bizarre angle on its body is not a styling choice. It is the solution to a brutal equation. To understand the shape, you first have to understand how radar actually sees. A radar station sends out a pulse of radio waves into the sky, then falls silent and listens. When those waves strike a metal aircraft, they scatter, and some of that energy bounces back toward the station. The radar hears the echo and knows something is out there. So here is the key insight that most people get wrong. Stealth is not mainly about soaking up that energy like a sponge. The real trick is far more elegant. You shape the aircraft so that when the waves hit it, they bounce off in almost any direction except straight back at the radar. If the echo never returns to the sender hears nothing. The target might be huge and still appear on the screen, no bigger than a bird. That single idea controlling where the energy goes explains the entire strange shape. A normal aircraft is a disaster for this. Its round fuselage, its curved engine inlets, the right angles where the wings and tail meet, all of these act like mirrors and corner reflectors, throwing energy back toward the radar from countless directions. To hide, engineers had to hunt down and eliminate every one of those reflections, and bend the leftover energy away into empty sky. The result looks alien because it was never designed for the human eye. It was designed for a beam of radio waves. The strangest part of the story is where the math came from. In the 1960s, a Soviet physicist named Pyotr Ufimtsev published a dense theoretical paper on how electromagnetic waves scatter off the edges of flat surfaces. It was pure theory, equations on a page, and Soviet authorities saw no military value in it. They let it be published openly, and it was even translated into English. On the other side of the Cold War, an engineer at Lockheed's secret skunk works named Denis Overholser read that paper and realized what it truly was. Ufimtsev had handed him a way to calculate in advance exactly how much radar energy a given shape would reflect. The Soviets had published the recipe for invisibility and discarded it. America picked it up off the floor. There was just one catch. The computers of the 1970s were far too weak to calculate the reflections off a smooth, curved surface. They could only handle simple flat planes. So the first true stealth aircraft, the F-117 Nighthawk, was built entirely out of flat triangular facets, like a black diamond carved by a computer that could only think in straight lines. Each flat panel was angled with care, so that incoming radar waves would glance off and shoot away into the sky or the ground, never back to the enemy. It worked astonishingly well, but the price was severe. The faceted shape flew so badly that pilots nicknamed it the Wobblin' Goblin. It was aerodynamically unstable and stayed in the air only because computers adjusted its controls dozens of times every second. The plane traded the ability to fly easily for the ability to disappear. Shape was only the beginning. The engineers attacked every other way an aircraft can betray itself. The spinning blades of a jet engine are a brilliant radar reflector, so the inlets were hidden behind serpentine S-shaped ducts that bury the engine deep inside the body, out of the radar's line of sight. Weapons, which would shine like beacons hanging under the wings, were moved inside internal bays. Every edge on the aircraft, the wings, the tail, the edges of every door and panel, was carefully aligned to point in the same few directions. That way, whatever energy did scatter would be concentrated into a handful of narrow spikes pointing away from threats, instead of glowing in all directions. On top of the shape, they added radar-absorbent materials, special coatings that convert a little of the remaining energy into heat. And the exhaust was flattened and cooled to hide the aircraft from heat-seeking eyes as well. As computing power exploded in the following decades, the harsh facets could finally soften. Engineers could now calculate the reflections off smooth, continuous curves, and the next generation, the B-2 bomber, the F-22, the F-35, traded sharp edges for sleek, blended surfaces that are both stealthy and graceful to fly. The shapes look less alien now, more like polished sculpture. But the same invisible rules are still hidden inside every curve. The math of Ufimtsev's edges is still there, just wrapped in a smoother skin. But invisibility is a fragile and expensive illusion. The radar-absorbent coatings that help hide these jets are notoriously delicate, sensitive to rain, heat, and humidity, and they must be painstakingly repaired after almost every flight, inside climate-controlled hangars by specialized crews. A stealth aircraft is one of the most demanding machines ever built to maintain, and a single scratch, a loose panel, or a smear of the wrong material can make it suddenly bright on a screen, and the enemy never stops adapting. This is a permanent game of cat and mouse. Stealth shapes are tuned against the short wavelength radar that guides missiles, but older, low-frequency radars see the world differently and can sometimes catch a faint glimpse of an aircraft they were never meant to detect. Defenders now link many radars together from different angles, hoping that a jet hidden from one will betray itself to another. Infrared sensors hunt for the heat of engines. Every advance in hiding drives an advance in seeing and then back again. And yet stealth has never meant true invisibility. In 1999, an F-117 was shot down over Serbia, brought low by clever tactics, old long-wavelength radar, and a measure of bad luck. The lesson was sobering. Stealth does not erase an aircraft from the sky. It only shrinks the distance at which it can be seen, buying precious time and surprise. A stealth jet is not a ghost. It is a machine that has been shaped down to the millimeter to give its enemy as little to hear as possible. So the weird shape was never about hiding from you. It is the visible fingerprint of an invisible war, fought in radio waves and won with geometry. It is the same lesson written into every machine built at the edge of the possible. The black of a submarine is the color of swallowed sound. The black of the blackbird is the color of survived heat. And the strange, folded shape of a stealth jet is the shape of a returning echo, bent away into empty sky. Look closely at anything that seems impossible, and its strangest feature will always lead you back to the same place. Not to a designer's imagination, but to the unyielding laws of physics, written this time not in steel or titanium, but in the silent language of the wave.